Hi, Asia.
Hi, sir. Good evening.
How you doing?
I'm doing okay.
All right. All right. I just going to wait a few minutes to for the others to join. Oh, 11 minutes gone already? Jesus. All right. I just going to wait for a few minutes for the others to join. Even one more. All right.
All right.
Evening.
Good evening.
Hi, Papa. All right. So, good afternoon again, and I trust that you guys are doing well. Trust that you guys are studying. Um, Remember, this is your first year of the bachelor's program, and guess what? Guess what? I have fabulous news for you. Anybody hear the news yet?
That we're getting break.
This is
Mhm. That's
oh,
not
it's the
it.
accredited thing that said.
If I tell you, me must told you.
Or the course
Me
accredited already, the program accredited, no?
talk truth.
Nice.
Talk truth. So it means that you are doing an accredited program. You're doing an accredited program. It is for me. I'm very excited. I'm very excited because I know the work, the level of work that was put into it.
Mhm.
I know what it entailed. I know the sacrifices. I know all of that. I have been there. Oh my goodness. I am excited, totally excited. Forgive me if my excitement is a little bit overpowering for you. It says Excelsior Community College, ECC, is the only community college in Jamaica that has obtained institutional accreditation from the University Council of Jamaica, the UCJ. Excelsior Community College, transforming lives, nurturing global citizens. I am excited. Congratulations, guys. Your program is accredited. Oh my goodness. It means when you would have completed your bachelor's, you can go anywhere in the world, including the UWI, to do your master's in environmental studies, natural resources, you name it. You name it. It is not only that your associate degree is accredited, too, we have a double accreditation for that because we had a programmatic accreditation for the associate degree. Now we have a institutional accreditation. Every program that the college offers is accredited institutionally. Big up on yourself and congratulations. You're proud of honor. You're proud of honor. Congrats, congrats, congrats. Congrats, congrats, congrats. Um, make sure that you make sure that you relish into this achievement. It is an achievement to give God thanks about and to celebrate. So, my congratulations to you. I'm so excited. Oh my goodness, you don't understand. I'm very excited. But anyhow, the work must go on. So, yes, we are institutionally accredited. Nobody can talk to you. Nobody can tell us you don't fufu program. That don't make it. Hold on a minute, please. I know one person who will be very happy is Michael because I know at the start of the environmental statistics, he asked a question. And even though we got unconfirmed words to say that, yes, we were granted institutional accreditation. I couldn't say anything because we never see it on paper. Now that we see it on paper, big up on yourself. Big up on yourself. All right. Let's go. I even lose my train of thought because of the excitement. Okay, so we were having some conversations and you guys caused me to laugh and I started reflecting on what it is that we were doing last class and me reflecting and I'm saying to myself, yeah, what is going to happen now? Give them homework and I bet you nobody's going to do it. And then boom, somebody came with the answer and I saw communication that, yes, sir, we looked at it and we recognize what it is that we were doing or what it is that we were doing. So for me, it proves the commitment that you give to me for learning. Only problem is that I have with the class is that some people just won't come out. Some of those again, but it is what it is. But the few that I see, I know you are working. And I just want to congratulate you. You have a lot to live for. You have a lot to accomplish. You have a lot to do to make history. You guys you'll be completing one of the first, well, maybe the second batch of students, the outgoing bachelor students will be the first to believe in the institutional accreditation, freshly minted. But you can say, I was there when they got it. So you two have a lot to celebrate. So now, we are going to be continuing our conversation. I'm proud of you. Yes, the answer was, what was it again? 50, what was it? 5,040. Yeah, 5,040. I have one more question to give you, and then I'm going to give you something that I want you to write out for me. I want you to write it out because I want you to be able to see what is happening. And in this case, we are going to be doing some calculations. And I want you to write it out. I want you to write it out. I want you to be able to write and see what is happening. So hear me out. This is a question for the road. A question for the road. Suppose I have a bowl. Suppose I have a bowl with 3 green balls, 2 blue balls, and 1 red ball. I have a bowl with 3 green balls, 2 blue balls, and 1 red ball. How many balls do I have in the bowl in total?
6.
6.
6.
Excellent. Come on, 6. And then I say to you, I draw a single ball at random from the bowl and report its color. I draw a single ball from the bowl at random and report its color. What is the probability that I will get a blue ball?
Sir, 2 of 6.
Which is simplified to
1 over 3.
1 over 3,
Very
1
good.
third.
Very good. Excellent. Excellent. Now, remember now, for those who may not see it, remember, you have a total of 2 balls, blue balls. But the total number of balls in your sample there is going to be 6. 3 plus 2 plus 1, 6. So the probability of selecting a blue ball a blue ball, you have two such balls. The probability of the event occurring is going to be 2 times because you have two such balls over the sample space. The sample space is going to be 6. So 2 over 6 or 1/3. Right? So, yeah. Everybody get that one?
Yes, sir.
Yes, sir.
Right. Now, I want to jump to something. I have a jar with 4 different colored balls. I have a jar with 4 different colored balls. And I choose one at random. Hmm. Hmm. Is the distribution over the color I get uniform or not? Is a question that we're going to be answering. I want you to just think about that one, and then I'm going to answer that question with you in a few. I'm going to tell you what the uniform distribution is. I'm going to answer that one for you shortly, but I want to jump to something else. I want to jump to something else, and I want you to take out a pen and paper because I want you to write. This one I want you to write. I want to know what is the distribution? What is the distribution over the sum of 2 fair dice? What is the distribution of 2 fair dice? And then I'll speak about the uniformity of it afterwards, but I want us to be able to write out the distribution of 2 fair dice. And I want you to say to me, if 2 fair dice are rolled, what is the sum of the possible outcomes? What is the total number of outcomes? If I roll 2 fair dice, what is the total possible outcomes I can have?
So 12, okay.
12? Write down your 12. Write down your 12. Anybody else? Hmm?
Um, the outcome.
Remember, I have 2 fair dice. I want you to tell me all the possibilities that I can possibly get.
Sir, 36. Wow.
You get 36?
Yes, sir.
Okay, all right. How you get the 36?
Hold on, sir.
Hold on, please. All right, Paz, I want you to start writing. Asia, you said 12. I want you to start writing. Didi, I don't hear from you. Oh, Didi is not there. Start writing for me, please, and let me see how much you can get out of it. Asia, are you are you seeing anything different?
Sir, I'm seeing the 36.
You're seeing the 36. How are you seeing the 36 now?
Sir, because it's two fair dies and each die has 6 sides. So um 6 to the second power.
Okay. Do you think you can write down all the possible outcomes?
Yes, sir.
All right. I want you to write down all the possible outcomes. A pair of you, so it's a strawberry in class. I want you to write down all the possible outcomes for me, please, and then I'm going to answer some questions thereafter. All right. Quick and fast.
All right, sir. They're finished.
Finish? I'm there talking to you and I'm still muted. Finish?
Yes, sir.
Yes,
All
sir,
right.
finish.
Okay. And how many got in total?
36.
36.
36. What is the probability of throwing a sum of 6? What's the probability of throwing a sum of 6?
So it would be 5 out of 36.
Agree, Asia?
Yeah, I got that too.
Very nice. 5 out of 36. Very good. What's the probability that the sum is going to be 13?
Um, 0.
Asia?
Yeah, so 0 to 36. Yeah.
What's the probability that the sum is 2?
One out of 36.
What's the probability that the sum is 3?
2 out of 36.
Very good. Asia, are you with him?
Yes, sir.
Good. Um, so let me just do a few more just to make sure that you guys are following what is happening. Um what's the probability of throwing the sum of 8?
5 out of 36.
Okay, Asia?
Oh, yes, sir. It's in the 5.
All right. Hear this one now. What's the probability of doing a 7?
6 out of 36.
Which is
1 over 6.
very good. Asia?
Also, I'm redoing it because I got 6.
Okay.
Yes, sir. I got it.
All right. So it should be clear that this distribution is not uniform, since the different events do not all have the same probability. You see what I'm saying? Is it uniform? No, because the different events don't have the same probability. We just worked out several different events a while ago, and they don't have the same probability. True or false?
True.
Yeah, man.
True.
So we said that it is the distribution is not uniform because we get different probabilities for our results. Different probabilities for our results. All right. So, any questions
Not so far. Everything is clear so far.
All right, good. So you've written down the full distribution over the sum of two fair dies. And you know, we have done some of the probabilities. We see where it says that it's not uniform. And I want you to be able now to see if you can get from the I'm trying to decide which one.
So, sir, like that last example, each time we're finding then the probability, we'd have to work it out like that and then count them.
Yeah, man. So you have to look at it to know what is happening. And there's a sequence. Matter of fact, I didn't ask you how it is that you did the stuff. There's a sequence in writing the stuff. You remember we did one with the I was showing you how to do the one with the balls in the bowl. We started 1-1, then 1-2, then 1-3, then 1-4, then
Yes,
1-5.
sir.
Yeah, man. So do it in sequence, because if you don't do it in sequence, just like when we did the probability tree, if you don't do it in sequence, we're gonna have problems, because we're going to guess and spell which is next. And we don't have time to guess and spell which is next. So once we do it in sequence, we can know. All right, I'm going to start with 1-1, 1-2, 1-3, 1-4, 1-5, 1-6. Then we finish with all the possibilities of ones. Then we move to all the possibilities of twos. 2-1, 2-2, 2-3,
1, 2, 2.
5,
Yeah.
6. Yeah, man. Go all the way down to 6-1, 6-2, 6-3, 6-4, 6-5, 6-6. So that should not take you, you know, very long to do. That should not take you very long to do. Yeah, that should not take you very long to do. Let me ask you a question. I don't want you to necessarily write it, but let me answer a question. What if I were to ask you to write the distribution over the sum of two fair dice, three rather fair dice that are rolled? What would be the total possibilities that we could get? That's all I'm going to ask you to do. I'm going to ask you to write them up. But if I said three fair dice are rolled and I ask you the total possibilities, what would you say to me?
216.
And 16, yeah.
Excellent. You guys are getting it. You guys are getting it. You guys are getting it, and I'm very proud of you for that. Very nice. 216 is correct. All right. What is the probability of getting a 3? What is the probability? We're talking about the same probability with the die. What is the probability of getting a 3 when you roll?
With the same two dice, pure dice.
Yeah, man. Yeah, man.
Or
Two die.
2 out of 36.
36, yeah.
2 out of 36?
Yes, sir.
What I asked you a while ago?
What's the
Getting a
probability
3.
of getting a 3?
Not the sum of 3, you know. I never said sum, you know.
Oh.
Getting a 3. So, you know, you roll the die, and one die will tell you, say, you have 1 or 2 or 3. What's the probability of rolling the die and getting a 3?
Or is it a third?
Sir, are we dealing with the same two fair dice?
Sorry, I stepped away a minute. Did you answer me?
I was asking if it's the same two fair dice or if it's one.
Two fair dice.
Sir, would it be a third?
Here's my question. What is the probability of rolling the dice, the two of them, and getting a 3?
0.
No. All right. When you roll one die, what are the probabilities of what possibilities can you get?
1, 2, 3, 4, 5, and 6.
Mm-hmm.
Yeah.
Mm-hmm. So what I'm asking you is, when I roll the two fair dice, what is the probability of me getting a 3 on one of the rolls? Not the sum, you know. And I'm talking about the sum of the rolls, you know. Are you getting what I'm asking you?
Sir, trying to.
Jacob, I'm asking you?
Sir, I'm trying to think about it. Sir, would it be 1 out of 36?
Mm.
Alright.
All right, let's go again. Say, for example, I roll the two dice, and I get 3 and a 1. Did I get a 3 in on one of the die?
Yes, sir.
Good. So I'm asking you, what is the probability of me rolling the two fair dice and getting a 3 on one of the rolls? Not the sum, getting a 3 on one of the rolls.
Oh, I understand, sir. Give me a second. Sir, would that be 10 out of 36?
Check again.
Oh, 5, 5.
Mm-mm. Mm-mm. Try it again, man. Try it again. You're closer the first time. Asia, come on, come on.
Sir,
What is it?
11.
11 out of 36 is correct. Look for the 11 paths. Okay.
Yes, sir. Is the 3, 3. I didn't count because you said the possibility of getting a 3 on one of the dice. So that's why I left off that one. And I got the 10. Hope it not sound so complicated when I explain it.
Say it again, Paz. Sorry, Paz. Say it again, please.
Yeah, so I was saying the question was what was the possibility of getting 3 and one of
Yeah, getting a 3.
yeah, and one of the dice. So I didn't end up counting the 3.
Why not?
That's why
Isn't
I got
that
the 10.
But isn't that a 3?
Yeah, but it was on both dice. So
In a
that's why.
business. That's
Oh,
in a business.
okay.
Yeah, in a business. You get that is that 3. All right. Now, so you have to read the question, and I can understand why you would have said the answers you were giving me before, because when I was in the calculation before, what I was concentrating on really was the we call it now I soon tell you the sums, right? But if they don't answer for sum, don't include sum in it. I don't know if you get where I'm going. If they don't answer for
Yes, sir. I
sum,
understand better.
yeah, man, don't include sum in it. So that's why I want to get you trying to get you into understanding what it is that is being asked. Now, this one is a trick one. What is the probability of getting a double on both dice?
Um, 6 out of 36.
Yeah, always remember that you need to write it in its lowest term. So you're correct, but it is now
1/6.
1/6. Asia, you see it? Asia gone?
Yes, sir, seen it.
You see it, good. No, you still want to change up the question. I never talked to you about a double before. But I said double now, and then you recognize, oh yeah, I'm talking about the 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. All right? All right, here this one. What is the probability of getting a 5 on the first die?
One over 6.
Very good. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Don't.
Yes, sir.
Right. Asia,
Sir, what's the answer?
1,
What
6.
answer? 1/6.
6,
Oh,
6 over 36, 1, 6.
oh, yes, sir.
All right. So what I'm saying to you is you have to look at the combinations. When you see the combinations, you're just going to work with the combinations. Look at what they're asking about with the combinations. All right? Hear me out. Go on. I'm gonna try and complicate something. I just want to. Aha. We're not going to get this one now. What is the probability that one of the numbers, what's the probability of getting one of the numbers being the square of the other number? What is the probability of getting one of the numbers being the square of the other number? It doesn't matter which order it is. The order is not important right here. What is the probability of getting a number that is a square on the other die? What is the probability of getting one number that is a square of the other number?
1/36.
Knew I got you right there. Which one do you think it is?
1/1.
2-1?
1 1.
When you square 1, you get 2, or when you square 2, you get 1. So that would not be an answer. You said
No,
1
as
1
in-
age up.
No, I said 1/1.
When I said 1 1, I thought you
Yeah.
said 2 1.
No, man, 1/1.
That's only one of them. Haha. Both of you got tricked. Look again in detail and see what it is.
Oh, 4 2.
Yeah, 2/4.
So it's 3 or
I say 1/1 and I say 2/4.
so 1 to 4 2. That would be 1 2.
What is it to be? Which one?
So
So
I
I-
would say 1 over 12.
Mhm.
You say 1 over 12?
Mhm.
All right. And I would agree with you. Paz, do you agree that it's 112? Do you agree, Paz, that it's 112?
Wait, so that is when you get 1/1 and 2/4
And 4 2.
and
And
4
4 2?
2.
Mm-hmm.
You can remember, sir, say them to the order.
The order doesn't matter
Okay.
here.
Yeah.
Based on what my question says. My question says, what is the probability of getting a number that is the square of the other number? So if you
Yeah,
get
I
a
got
4 and then you get a 2, that means the 2 when you square the 2, you can get 4.
Yeah.
If you get a 4 and 2, when you square the other 2, and you can get a 4. And 1, when you square 1, you can get 1.
Yes, sir.
Good. So I don't need to see what is happening with the combinations. So if you're going to the exam and they give you a combination like that, what I want you to do is to write down your sample space. They won't give you, remember I asked a while ago, what if I rolled 3 fair dice? And I asked you what is the sample space and you work it out and say 216? You won't get a 216 in the exam to write out because that is going to be way too much to do. But they can give you a 36 sample space because it is easy. It is easy. I mean, you can use less than a minute to write this out, one out. True or false? Talk to me.
Yes, sir. True.
Come on. And then when you have written it out, you just look at the possibilities. Just look at it and see which one fits it. And I mean, if you get something like that in the exam, you should get full marks. Hands down, full marks. I mean, you don't have to worry about it because it is full marks there for you. Why did they say though fair dice? Then 2 fair dice are rolled. Why they use the word fair? Why do you use the word fair?
Because some dice are unfair.
What do you mean by that?
There's somebody I try gamble and mess up the numbers. Mess up somebody else.
Yeah, you're supposed to roll a 6 and there's no 6 on a die.
Yeah.
It's 2 5.
Yeah.
There are 2 5s. You have 1, 2, 3, 4, 5, and 5. You see?
Yeah.
Yeah, man. Or you may have 1, 2, 3, 3, 5, and 6. So there's no 4. So all the roll you roll, I try to get a 4, you can't get a 4, you can't get a 4, you can't get a 4. And you unsuspectingly don't know that there's no 4 on the die. And then some die again would be in such a way where one side you may not ever get a number on one of the dice because if it drops on that side because the table on which you're using could be magnetized, positively charged, and the die could be positively charged on that side. So if it goes on that side, it just flips over because it is repelling. You see what I'm saying? So in that case, it will not be a fair die. It will not be a fair die. Asia, how you feel?
Oh, feeling good so far, sir.
All right. I just want to I want to read something for you. I want to read something for you. It's not anything too long, but just for you to understand the whole business of what is uniform versus what is not uniform. So let me share. Even though we already did some calculations on probability distribution, I nonetheless want to just go through something here with you. All right, so I'm going to read through, and then you're going to let me know whether or not you are following what is happening. So it says, hopefully you have developed some intuition for probabilities at this point, and I know you have. Before going further, we should formalize what makes a probability. Mathematically speaking, to do so, we first need to define mutually exclusive or disjoint events. So we have events that are mutually exclusive or disjoint, and these two events are mutually exclusive if. So when you see the IFF means if and only if. So IFF means if and only if. It means if and only if. So it says two events are mutually exclusive if and only if they contain no outcomes in common. That is, both events cannot occur at the same time. Can you ride a bicycle? Can you ride a motorbike and eat a box food at the same time?
I wouldn't recommend it, no.
I wouldn't either. I wouldn't either because you could be very dead, right? So something like that could be a mutually exclusive event because the events just cannot occur at the same time, right? So when you talk about an event that is mutually and I'm going through this because we may not have any calculations here. You may get questions on the multiple choice that will say a mutually exclusive event is, and you get some options and you have to read. So you have to understand what mutually exclusive events are, and those are events that cannot occur at the same time. They are disjointed. The events cannot occur at the same time. Can you think of two events that cannot occur at the same time? And let us check to see if it is mutually exclusive. What two events? I'm giving you one here. If I roll two dice, the event to get a total of 7 and to get a total of 8 are mutually exclusive. Are mutually exclusive because there is no way. The most I can get is a total of, if I roll 2 die, Well, I won't say the most.
Sorry, I mean, like, give you a scenario, like,
Yes.
say,
Scenario, yeah.
working out while sleeping.
Well, I can do that. Because in my mind, when I will dream of getting a six-pack, and in my dream I will say, yeah, I have a six-pack, but of course, that like some people, would want to get a six-pack but don't want to go to the gym. Yeah, that is like
Yes,
that. But
sir.
yeah, but that's a good one. And stop throwing words at me here. And Michael. Asia, let me hear you, Asia. Which one?
Breathing on your own while underwater.
Say it again.
Breathing on your own while underwater.
Well, somebody could say that I could be assisted with a breathing tank,
That's what I say on your own.
but I will still be breathing on my own, but being assisted with a tank.
Hmm.
I don't know if you see where I'm going, but I guess what you're saying, you know. As I say that, I don't know if you saw on the news early this morning. I got up at about. That's why I feel the way I feel. I went to work today and I was like, oh my goodness, I just want to go home and sleep. I got up from about 3 o'clock today, and couldn't go back to sleep and couldn't go back to sleep. And when I picked up the phone, I saw where, oh goodness, I don't want to tell a lie. Don't remember the country. Hold on, please. And a cargo ship was going through, and it somehow collided with a bridge.
In Baltimore.
Baltimore, that is it. And moments later, the bridge just collapsed. And unfortunately, there were cars on the bridge. So they were plunged into the water. Now, let me tell you something. You see, the mere fact that me say my car got in the water, me know me dead. As neat. And I'm just waiting now for class to finish so that I can go and follow up this news, because I am sure there were persons there who could not get out, because if they didn't recognize what was happening and to react swiftly by turning their windows down, once that car is submerged, the power is disabled, so them can't open not even the door because of the suction now that is taking place. So the door can't be open, the windows can't go down, the car is filling up with water, so they're going to drown.
Yes, sir. I heard a couple people died.
And it is, oh God, it is just, when I saw it this morning, it had just happened. And so there were no reports of deaths. And I'm saying to myself, oh my goodness. I mean, video cameras around the thing showed where um video cameras showed where the bridge was just collapsing. I mean, it's like a live collapse. And I was like, oh my goodness. So, oh Lord. Anyhow, so a mutually exclusive event is an event that cannot occur at the same time. All right? All right, so let's go. Now it says, 1 minute. Where am I? Okay. It says, now suppose we have a set of n mutually exclusive events that together cover all possible outcomes in our sample space. S. Such a set is called a partition. And look at what the partition looks like. The partition looks like this here, right? So we have a set of n mutually exclusive events together cover all possible outcomes. So this is my sample space. All of what it is that you see in here is representing my sample space. But within my sample space, I'm going to have a partition of the sample space, and a sample event would be flipping a coin where S could be either a head or a tail. So therefore, we define N, or partition, to be two, either a head or a tail. So the mutually exclusive event could be E1, which is a head, and E2, which is a tail. So it's either one or the other. Another example might be rolling two six-sided die, where the mutually exclusive event are getting a total of 2 or 3 or 4 or 5 or 6, all the way down to 12. And we did something like that, true or false, and we did get the 11, don't it? With the number of 3s showing on the first die. Or not the first die, the 3 occurring in one of the throws, right? So the partition is just having your sample space and showing the mutually exclusive events taking place in that sample space. So in this particular one, you will have 4 mutually exclusive events taking place. And the boundaries was here, so for this one, down here say can't pass here, so, and up here, so the one here large, and the one here just one little piece up here, so. Follow me?
Yes, sir.
All right.
Yes, sir.
So it says a partition of the sample space into 4 mutually exclusive events. The rectangle represents all the outcomes in the entire sample space. As I said to you, this is my entire sample space. All of this is my entire sample space. And each labeled region represents the outcome in that particular event. So what you're going to have right here is the event 1 taking place only right here, so nowhere else, just right here, so. Now, when we assign a number, the probability of EI, where I is going to be a number, EI to each of the events, EI in the partition, if and only if the following properties hold, then the probability of EI, one of the events occurring, can be considered a probability of the set of values E1 all the way down to EN. And E1 is the first event, and EN is the last event. So if you have 4 events, it's going to be the probability of event 1, probability of event 2, probability of event 3, probability of event 4. So when you say the probability of EN is the probability of the last event, N is just representing the last event, right? And then we're going to consider having a probability distribution. You don't have a problem, you shouldn't have a problem with this because we did probability distribution some time ago, right? But I didn't speak to you about the mutually exclusive events, so I'm telling you what it is now. And remember the properties here, that the probability of EI, the event occurring, must be either 0 or 1. One extreme to the next. Probability of 0 is the probability of it not occurring. It is impossible. Or the possibility of this one being a surety. You remember we spoke about that last class?
Yes, sir.
And I said to you that it is no fun when the probability cannot occur or the probability is at a surety of 1. The fun comes when you have the probabilities on the inside, 0.52, 0.61, 0.98. All right, that's where the probability comes in. And then the second and final property is the sum of all the probabilities. See, the summation from I equals 1 all the way up to N, I equals N. The probability of that event occurring, the sum of the probability of that event occurring is 1. The sum of all the events cannot be greater than 1. We had that conversation before, true or false?
True.
Yeah, man. So the probabilities, Asia, are you back with us or are you going to eat?
I'm gonna eat it, sir.
Right? So the sum of the probabilities is going to be equals to 1. And remember, the probability of the event occurring is going to be at 0, where it just definitely can't occur, or it's going to be at 1, where it is most obvious that it's going to occur, right? So from one extreme to the next. So the probabilities of every little piece of event that is occurring in the experiment, the sum of those probabilities is going to be equal to 1. So what I'm saying to you is, go back to the probability of throwing 2 dice. And you write out the sample space of 36. When I look at all the probabilities of doing all of those questions and getting the 1/6 and the 11/36 and them something here, when I add up all those probabilities, you know, them are going to come up to 1. The sum of those probabilities will have to be equal to 1. Can't be greater than 1. There is no way I can get the combinations. And when I get the combinations, they're going to be 1.5 or 2 or 3 or 4. The sum of the probabilities must be equal to 1. Cannot be more than, cannot be less than. The sum of the probabilities must be equals exactamente to be 1. All right. And then finally, just to read through here with you, I think that is right. Finally, right here, it says every probability must fall between 0 and 1, inclusive. And the sum of the probabilities of the mutually exclusive event that occur in the sample space must equal 1. Hands down. One way to think of the probability distribution is that altogether the sample space S has a unit of probability mass. And this mass is divided up in some way between all the EIs. Remember, the EIs are going to be my events, my different events that are occurring in that sample space. Right? Remember, the event is a subset of the sample space. Remember that?
Yes, sir. I remember saying that, sir. Yes, sir.
Right. Good. So it says then that the amount of mass assigned to each event is what we call the probability of that event. In our flipping of a coin example, 2 events are equally likely. So the mass is divided evenly, and we can get a probability of 1, which is going to be equal to the probability of 2, which is either a head or a tail. And that's going to be a half. Right? So this example is going to be an example of a uniform distribution. A distribution where all the events in a partition are equally likely. So when you flip a coin, you can get either a head or a tail. If you get a head, the probability is 1/2. And if you get a tail, the probability is the same thing as 1/2. So are the answers the same, uniform, for the probability of getting a head or the probability of getting a tail? That's a question.
Yes, sir.
So therefore, that is a uniform distribution. So if I say to you, if I flip a coin, what is the probability of getting a head? Asia says, sir, 1/2. And I say, Paz, what is the probability of getting a tail? And your answer is 1/2. It means that I get the same result. So that is going to be an example of a uniform distribution. That is a distribution where all the events in the partition are equally likely. Now, another example of a uniform distribution is a distribution over the number we get when we roll a single or fair die. What do I mean by that? What's the probability of getting a 3? It's going to be 1/6. What's the probability of getting a 4? 1/6. True or false?
True.
Yeah, man. So the probability will be uniform, so therefore it's a uniform distribution. So since the probability distribution is defined as a function from event to values, it is sometimes called the probability mass function, which is a function that allocates the probability mass to different events. So we looked at some more probabilities today. Look at some probability distribution. One of the things that we looked at is to speak about the distribution of rolling 2 dice. And we get in our sample space to be 36. I went far and asked you, what if I roll 3 dice? What would be the sample space? And you correctly said 216, because it now becomes 6 raised to the 3rd power. We also looked at different probabilities we also recognize that the sum of the probabilities is going to be equals to 1. We also look at uniform distribution. Uniform distribution is when the result of the probabilities will be the same for each event. For example, when you roll a die, the probability of getting a head is 1/2. So as it is the probability of getting a tail. When you roll a single die, the probability of getting any of those numbers will be the same. So the distribution is uniform because the probability of getting a 6 is 1/6. What's the probability of getting a 1? 1/6. Probability of getting a 3, 1/6. So we talk about those being a uniform distribution. Fair enough?
Yes, sir.
All right, we're gonna end it right there. We're wrapping it up nicely. We're ending right there. I recognized something late last week or maybe recently that school closes tomorrow.
Sir, I saw Thursday on the email. It said Thursday.
It says it's all Thursday.
And yeah, and opens it
4th?
goes back on the 4th. We come back on the 4th. Class resumes on the 4th of April. That's what I'm
All right,
seeing.
but in that case, then we have class on Thursday. Thank God, because I was a little worried. So I guess once it is at the provider link, we have a class on Thursday.
So this is what it says. Please note that the college will be closed from March 28th to April 1st, 2024. Classes
Also no
resume on
class.
April 4th.
That
Oh,
means it will be closed on Thursday.
It will close on Thursday, then pass.
Yeah.
Yeah.
So
it
tomorrow
says
is the
close
last
public.
day.
So tomorrow is the
Okay.
last day. So we're having
Yeah.
a class until the 4th.
Next week.
Next week, Thursday, the 4th. All right, don't worry about it. We're still connected to our WhatsApp. I'm gonna ask you to use that week that you get, for purposefully to complete your EducaSoft and to do some studying and get yourself ready for these exams. I guarantee you should be fine. But one of the things I want to do, we've been through a whole lot of stuff, and we've been through quite a bit of formulation. You need to remember the formulation to calculate the different stuff, the correlation coefficient, the least squared regression, the measures of central tendency, mean, mode, median, all of those formulations we need to put back to memory, because we're going to go into the exam and they're going to give you questions based on those. And I'm expecting you guys to answer pretty well. So you're going to use that week and you're going to study. Please and thanks. We have an agreement?
Sure, so we don't know that I don't want to go circle right now.
Yeah, but guess what? You have the coursework, but you can't just sit down and just do coursework like that, because by the time you come back, it's going to be exam time and you're going to be left behind. So you're going to do some coursework and say, I am spending 5 hours on the coursework. Say, for example, Holy Thursday, you are. Say Good Friday, but you know you're not going to work because, Asia, you'll be off. You're off already, Asia, you're off tomorrow.
Friday only.
You're getting Friday only?
Friday and Monday.
So
All right,
me
so
not getting no holiday.
For you.
Well, based on the nature of your job. But what I'm saying to you is, say, Asia, you have a day, Friday. You go to your church, you do your reflection, you do your stuff, and all of that. And then you're going to say, all right, I'm spending 2 hours on, you're doing engineering geology now?
No, sir.
All right, you're doing the built environment. Right. You're going to spend
Yes, sir.
you're going to spend 3 hours on the built environment. You spend those 3 hours are done.
The sleep.
No. When the 3 hours are done, the 3 hours are done. All right? When the 3 hours are done, the 3 hours are done. No. When the 3 hours are done, the 3 hours are done. And then it's time for you to move on to another thing. You get me?
Yes, sir.
All right. And I'm going to follow through with you, to make sure that you know what it is that you're doing. All right?
All right, sir.
Okay,
That's
sir.
pick up yourself. Talk to you.
Sir, before you leave, one question.
Sure, go ahead.
About the question with the 3, the possible outcomes of 3. So you're sure it's 11? Why
You don't
would
get
it
11
count the double 3? Because when I count it
because
without double 3, I get 11. And when I count it with it, I get 12.
because I did not say to you to get 1 3. I said to get a 3.
It's to get a 3. So that would you count the double 12 then? The double
The
3
double
then?
3? Yes, ma'am.
So but that would be 12 then.
No, you know 12 is 11.
Unless me not count it properly. 1, 2,
Count it again, man. Count
4,
again.
5, 6, 7, 8, 9, 10, 11, 12.
6. Um, 6. You get 6 right there. 7, 8, 9, 10, 11. What are your 12? Tell me your 12.
1, 3, 2, 3, 3, 1, 3, 2, 3, 3. That will count as 2. And 3, 4, 3, 5, 3, 6,
Hold
5,
on.
3.
You said 3, 3. You can count 3, 3 as 2?
Yes, sir. That's what I was asking. If you count it as 2
No,
or 1.
no, it's 1. Count it as 1.
Oh, okay. That's fine. All right. Thank you, sir.
All right, cool.
All right. Bye-bye.
Bye bye there.
All right, bye.
All right, easy pass.